All right, 6.1. This is all about equivalent forms of exponential expressions. Students will be able to determine whether pairs of exponential expressions are equivalent and rewrite a given exponential expression in a specific form. Okay, so in order to do this, we have to be very fluent with some rules here. So I'm going to recap some stuff here. It's all explained here. If you're confused with what I'm saying, I would definitely encourage you to read through these. But basically, if you are multiplying two different values but they have the same exponent, you can just pull the exponent outside and multiply them together first, right? Same thing with division. Two different values with the same exponent, you could write it as one fraction or one division thing with the exponent on the outside. Okay, so that's the same exponent, different bases. What about if it's the same base, different exponents? Well, when you're multiplying with the same base, that's like adding with the exponents. And when you're dividing with the same base, that's subtracting the top exponent from the bottom exponent. You could think of that, that works because, like, let's say I had x cubed over x squared, and that's like x over x times x. Well, cancel out two of these, cancel out two of these, and I'm left with just x to the 1, or one out of the x's. And that's essentially what we get with 3 minus 2 is just x to the 1. And so that's kind of how that works. In a similar way here, if you have x to the 3 times x to the squared, that's like 3x's times another 2x's. That's a total of 5x's. So this is actually, a lot of these are actually rules that you've already seen before, but we just need to be fluent with them. Another thing you might see is if you have an exponent, so you have some base to an exponent, and then it's inside parentheses and raised to another exponent, that is like multiplying the exponents. This is really important because you might see a problem that looks like this, and you might have to rewrite it so it looks like this. So we have to be fluent with that. An exponent to an exponent, as long as one's in parentheses and one's out, is just multiplying exponents. Okay, and the other thing that's really important to remember is that a negative exponent really just means that you're dividing. So you could take the negative and you can move it onto the bottom like this. Okay, again, these are all rules that you probably have seen before, maybe in Algebra 1 or pre-algebra, but we have to be very fluent with them because now we're going to use them to solve some pretty fun problems here. So I have my little hint. Sometimes there's not exactly just a specific way to do this. You just kind of have to play with the values until you get something that works. So for example, I'm looking at this one. It says determine whether each expression is equivalent to the expression below. So the first thing I'm going to look at is see, okay, which one of my rules apply? And the first thing that I see is that I have common bases and I'm multiplying. So I'm just going to start writing the different ways that I can write this. So I first of all see that I could write this as 3 to the 9m squared plus 9m. Okay, I'm just putting a line so you see that's all the exponent. And I could do that because they have the same base, and I could just add the exponents. That is one of my options, so I can go ahead and just circle that. I know that's going to be it. A lot of these problems, though, there's more than one correct answer. So I'm going to play around with this a little bit. One of the things that I can see that I can do here is I could factor in the exponent. I could factor out a 9, and I could factor out an m. So I could think of this as 3, 9m, and then m plus 1. And we said earlier that if you're multiplying, if you're multiplying here, then you could put it inside parentheses. So there's quite a few things that we could do here. It's pretty crazy. I could think about breaking down this 9 as 3 times 3. Right, I could think of that as 3 times 3, and so one of the ways that I can write this is 3 to the 3rd times 3m plus 1. And since I'm multiplying, I said that when I'm multiplying, I can actually just go back and think of that as inside parentheses. And 3 to the 3rd is actually 27, so I could think of this as 27 to the 3m plus 1. Well, none of these have a base of 27, so I don't think that's right. And when I did have a base of 3, I did not have 18m squared. It looks like they're thinking maybe you would add these two together to get like terms, but there's no way to do that because this is m to the 1 and m squared. So I don't think that this one is at all possible. And I'm trying to figure out if there's any way that I can get to a 9, but in order to get to a 9 in here, I'd have to be able to factor out a 2. I was able to get to a 3. See how they have a 3m? If I was to actually distribute this back out, that would be a 3m squared plus 3m. But when I do that, I get a 27, not a 9. So it turns out that that is actually incorrect as well. So just from playing around with it, seeing what I can do, I was able to figure out what what could potentially match and what could not potentially match. I'm not expecting you to be pros at this right away. It's going to take you a few tries of playing with these before you get pretty good at this. But the idea here is I didn't have an answer right away. I did one thing. I found one answer. But I wasn't sure that these were not right until I just played with it a little bit. Again, these types of questions, oftentimes there could be more than one right answer. So as you look at practice number 1, keep that in mind. There could be more than one right answer. Why don't you give practice 1 a try, see if you could find which ones there are correct and which ones are incorrect. Okay, so the first thing I saw when I was looking at this is this little minus sign. And to me, that tells me that I can divide. So I went ahead and wrote this as 81t squared divided by 81 to the 0.5t. Then I saw that that 0.5, I could kind of think of that as in parentheses, and I could just think of that as 81 to the 0.5 or 1/2 power. Important to understand that a 1/2 power is the same thing as taking a square root. I don't know if you've seen that before, learned that before, but I think you do that in Math 1, but that's important to know that a 1/2 power is the same thing as taking a square root. So the square root of 81 is just 9, and so I could just write this as 9t on the bottom. So we have 81t squared over 9t, which happens to be version A, so I know that one is correct. Well, then I looked at B, and I was wondering if I could get it to look like any of these forms, and I was seeing that these ones have the same exponent, so I can actually multiply 3 times 27, and that gives me 81t squared. Here, these ones have the same base and the same exponent, but if I think about the base rule, common base rule, that means I can add these exponents. 0.5 plus 0.5 is 1, and so that's 1t. Well, that happens to be exactly what I have here, so those are the same. Here I saw that they had the same exponent, so I thought, okay, I could actually divide. So 27 divided by 3 is 9, and 9 to the t squared minus 0.5t. That is no way that could be equal, because the exponents are exactly the same, but the bases are different, so there's no way these two things could be equal. So only A and B are correct options here. All right, let's go to the next page. Okay, so these functions are a little tricky. So let's take a look at example number 2 here. I'm going to zoom in. And they want me to solve for A, right? So find the value of A that makes the following equation true for all values of x. So basically I'm solving for A, but it's weird because there's an x in here as well. Well, I'm going to first, before I do anything, I'm just going to try and get these things to look somewhat similar in their form. And I see that this side has an x in the exponent, and so I want just an x in the exponent here. So one of the first things I do is I notice that these things are multiplying. That means that I can think of this as parentheses here. So if I was to rewrite this, it'd be 1/9 parentheses to the x equals a to the -7th parentheses to the x. Well, that means if they both are equal, right, and we have this x out here, that means that anything inside these parentheses has to be equal as well. So I'm just really thinking about what's inside here now. And so if I rewrite this, this is just like saying 1/9 has to equal a to the -7th. See, I don't even care about the x's anymore because I already know that what's inside these parentheses has to be equal because this whole thing is equal. The actual math behind getting rid of that x's would, you could think of it this way. It would be just like taking the x root of both sides. If you took the x root of both sides, the x's would cancel out. Okay, so now we're left with just this equation. And so again, I'm just trying to solve for a. So how could I get rid of this exponent? Well, to get rid of the exponent, I want this thing to end up, the exponent to just be 1. That would be a all to itself, is this exponent is just 1. So what would I need to do to this exponent to get it equal to 1? Well, the reciprocal. If I was to multiply this exponent by the reciprocal, which is -1/7, then it would be equal to 1. But I'd have to do the same thing over here, which means I'd have to raise this to the -1/7. So on the left now, I would have 1/9 in parentheses raised to the -1/7 equals 2. You could go ahead, you could try this in your calculator, but -7 times -1/7, that just equals 1. And so this whole thing is just a. And so that is essentially my answer. Now, I can rewrite that quite a bit. I could simplify it quite a bit to make it a little bit more streamlined. Remember that a negative exponent really just means that you're doing the reciprocal of the base. So 1/9 to the negative 1/7 is the same thing as 9 to the positive 1/7. So that's the same thing. And remember that a fractional exponent, this may be a stretch back, but a fractional exponent is the same thing as a root with whatever the denominator is in the crack there. So this is like the 7th root of 9, which you could plug in your calculator, get a decimal, but either one of these answers is a good simplified version of that answer. Pretty tricky stuff, I know, kind of fun. Let's go on to practice number 2 now. So I'll get you guys started on practice 2, and then I want you guys to try and simplify it on your own. One of the first things that I recognize with practice 2, though, is, again, I got these x's up there. And so I want these two things to look exactly the same. I want there to just be an x in the exponent. So I know I already have parentheses, but I could just kind of think of another parentheses again. I can do that because we said if they're multiplying, you could bring one of the parts of the exponent that's multiplying inside parentheses. So when I do that, mathematically now, technically, I have 1/4 parentheses to the negative 5 power, another parentheses x equals a to the x. Well, this is just like the last problem. Whatever's inside these parentheses has got to be equal to this. So I can just rewrite it with what's inside. Oops, didn't mean to change colors there. Let's change it back. Essentially getting rid of these x's as exponents. Once again, there is a mathematical operation here, taking the x root. You don't really have to do that. I'm just showing you that as an explanation of what's happening behind the scenes. But essentially, since these are both being raised to the power of x and they're equal, therefore the bases must be equal, and that's how I got here. Okay, remember that negative sign. That means the reciprocal of the base. So essentially, this is the same thing as the reciprocal, which is 4 to the 5th power. And you would just leave it like that because this number is really big. I mean, you can plug it into your calculator. When I plug 4 to the 5th in, it's not too big, but it's the same thing as, so 4 to the 5th is also the same thing as 1024. So either of those is fine as an answer. I would totally accept just leaving it as 4 to the 5th in this situation, but you know, have a calculator handy so you can simplify if necessary. Okay, that's it for the 6.1 notes. I know it's a little bit complicated, but we're going to be doing problems like both of these. I think the first set of problems is actually a little bit trickier. This is just solving, and to solve, you want to get them to look the same, right? Okay, see you guys on the next video.